If we carry weight, we have to be able to lift that weight. So we have to supply more lift, and when you supply more lift, you have more drag. More drag means more fuel burn, and more fuel burn means more operating costs.
Wing design is where lift and drag really matter. Even before it's built, A3XX's wing is a major design challenge.
The wing will be assembled from many components. The wing skin's typically of aluminium alloys, but we're running into the limits of the size of aluminium billets that can be produced by the manufacturers, and those are just the physical volume of aluminium that can be cast at any one time.
If you have to weld several metal sheets together, the wing gets heavier and potentially weaker. A structural failure in flight would be unthinkable, so it's vital to test a wing's strength. They are bent at various degrees to measure how much pressure they can withstand before the inevitable happens. Structural strength's an issue for all wings, including these on an Airbus A340. At almost 200 feet, the biggest wingspan Airbus currently produce. But it's still 25 feet shorter than the wing Chris Voisey needs to build.
On the A3XX, we're going to be challenged in terms of size. In an ideal world, we wouldn't have any joints at all. We'd buy a single piece of material to cover the whole of the bottom skin of the wing and again for the top skin. But simply, materials in that size are not available. So what we're going to have to do is either look at the use of alternative materials at the outboard end, or using some new technology to join the basic material before we do the machining together.
The quest for this new technology is led by Janet Mitchell. She runs Airbus's Materials Research Lab. The cutting-edge research is kept secret. So secret, we can't show you all the machines. This is where new technologies, some never used before, will be tried on A3XX.
It's a larger product. Therefore, we need to develop new materials. Alongside the new materials, because we've got large structures now, we may have to develop new manufacturing processes to cater for the manufacture of those structures. So we do need to be on the cutting edge of the technology.
Janet and her team have spent years developing a way of welding without welds. This machine joins two separate metal pieces together without melting them. It does it by joining their molecules together. The drum rotates along the joint, causing friction and heat. Not enough to melt the metal, but enough to soften it. Then the rotation stirs the molecules of the two metal parts together. The two pieces become one at the molecular level. They've christened this remarkable process Friction Stir Welding.
The friction stir welding process does not actually melt the material. It takes it to just before the melting point of the material. It makes it plastic. Whilst it's making it plastic, it's stirring the material. As it traverses along the component, it's stirring the material behind it and mixing the two materials.
But all this innovation will be pointless if Airbus can't sell their new plane.